Welcome to this, the third module in our microlearning course on command line programming. In this we'll look at the common Unix commands, at what they do, and how they can be combined. I've opened a terminal window, and I'm going to create a new file named myfile.txt, and I'll do it using the touch utility. Touch simply updates the last update time of a named file, or, if the file doesn't exist, then touch will create it. And running the ls command confirms we now have a new file called myfile.txt. The file is empty, of course. Touch has not added any content, so let's add some, and one way to do this is with the echo command. Echo simply echoes its argument to its standard output, which, by default, is the screen. So this simply prints, "Hello world," on the screen. We can redirect the output using the redirection symbol, like this. Now instead of displaying "Hello world" on the screen, echo will put it into myfile instead. And running the cat command on myfile will confirm it. This ability to redirect output is important. Every Unix command has two outputs, standard output and standard error. And you can also split these and redirect them to different places. For example, we've seen that this'll put "Hello world" into myfile. But it'll also put any error messages there as well, and this may not be what you want. So Unix allows us to send the standard output to one file, and the error messages to another. This'll put "Hello world" into myfile and any error messages into another called log file. Unix also allows you to append output to a file's existing content. By using the double redirection symbol, you can tell echo to append an error message to the end of log file, instead of replacing it. That way you will be able to see all the error messages in chronological order, which will help you later identify any problems that occurred when your script ran. You can redirect the output of pretty well any command, and use it to create a new file, append to an existing one, or point it at the standard input of another command. So, to add another "Hello world" to myfile, we can rerun the echo command we ran earlier, and simply change the redirection symbol to append. Now, here's a useful tip. Unix remembers all your old commands, and pressing the up arrow reveals them. So when you want to rerun a command you've used before, just press the up arrow until you get back to it, then pressing enter will rerun it. And rerunning the echo command we used earlier, but changing the redirection symbol to append, will add another "Hello world" to myfile.txt. And rerunning the earlier cat command will show us that myfile.txt now contains two hello worlds. That pretty well wraps up the demo on redirection, but this ability to connect different commands together is what Unix programming is about. The Bash language is quite simple, but its great strength lies in its ability to connect powerful Unix commands together and arrange them into pipes. The man command displays pages from a comprehensive, if a little cryptic, Unix manual. We saw how the ls command lists the contents of a named folder. ls is pretty straightforward and doesn't seem to need a lot of explaining. But despite its apparent simplicity, running man on the ls command generates nearly 400 lines of explanatory text. That's because ls, like most Unix commands, has a great deal of functionality, and that's why man is important. So, take the time to read the man pages for all the commands you're likely to use. You'll probably not remember the detail, but you'll know where to find it when you need it. By redirecting the output of man ls into myfile, we'll get a detailed explanation of the ls command. But if we try to use cat to display it, we'll only see the last 20 or so lines because it's too big to fit on a single screen. We can find out how big myfile.txt is by piping it to the UnixWC utility. This simply counts the lines, words and characters, and it'll tell us there's 388 rows, 2,326 words and a whole lot of characters. To deal with this, Unix has a utility called more, which much the same as cat, but stops scrolling the display after each screenful and waits till you press the spacebar to continue. And that's it for this assessment. In the next we'll look at variables, arrays, loops, conditionals, and case statements. However, in order to use those successfully, we'll need to create scripts, and for that we'll need Vim. This is a text editor that was derived from Vi, which was the original editor shipped with Unix back in the dark ages. In the next module we'll look at Vim and try to discover why in a world where really good apps have a lifespan measured in months, Vim is still the front runner after 40+ years.